if you remember in the video where I talked about assignment operators, we were specifically talking about, for example, let's take the AND operator. If I can even draw it properly, that's how you draw it. Ampersand equal to, and we said that this means that we are saying x equals x and y. So we're taking this and we're assigning it back to x using this shorthand operation. But now what I want to talk about right now doesn't involve assignment. So I just want to talk about this. So the operation itself. So the question is, how can we get the output? You can either print it out exactly as it is, or you can store it in something else. So we're trying to move away from having that assignment operator, which is what we covered in the previous video. So now we're just going to talk about the operators themselves. So since we've covered the basics behind them, I'm going to go through this fairly quickly, but there is one new operator that I'll cover. So let's get right into it. The first operator that I want to talk about is the AND operator. So this is the Bitwise AND. I've already created the file as I started the video, and it looks like that. So now, as I said, we have two options. We can say, so let's set our variables. Let's say x equals 4 and y equals 2. So these are quite simple numbers to work with, and that is why I chose them. I'm sure I also used these in the previous video. And now what we're going to do is we're either going to say we want to find the result of that, x and y, or we can assign this first to a variable z and say that. So we're assigning the value or the result of x and y to z, which means we can go ahead and print z. So these two things do the exact same thing. That over there and this, they do the exact same thing. Just that in this case, this is not stored anywhere. It just takes the result and it prints it. So if we run that, we do expect to get the same answer. Now it's up to us which one we use, but here's something that I want to bring to you, which is quite interesting. We've talked about f strings in a previous video, so let's use some f strings. Let's put some of the stuff which we've learned in the series together. So now I'll go for this second method so that we can actually use our variables. So let's erase this, and we're going to keep this option, right? So we're going to say print, then we're going to use f strings, so f quotation marks. Then you're going to say that the value, so these curly braces mean that we're taking the value and not x itself. So if you had this, it would just output x, as in x, the letter. But now when you introduce the curly braces, you take the value of x, which is 4. So now we're going to say 4 and this and is not in any curly braces or anything like that. So it should come out exactly as it is. Then this other one, we want to take it as a value, so we're going to say that. Then the equal sign will come out as it is, and we want to find the value of z, and z holds the result of x and y. How do you compute x and y? Well, this operator first converts x into binary, and please note, here's another important point, so NB. These bitwise operators only work on integers. So it can't work on numbers that have a decimal part. So these only work on integers. And now, taking 4, we first convert this into binary. 4 in binary is 100, and 2 in binary is 10. So now we just added that 0 over there, just so these things could align. So we have 0, 1, 0, and 1, 1, 1. And we're going to apply the AND operation. So if you apply the AND operation, and this is what's going to happen. AND says that to have a 1 as your result, so to have a result of 1, you must have one of them as 1 and the other as 1. Everything else leads to a 0. So you can view this as multiplication. 0 multiplied by 0 is just 0. 0 multiplied by 1, 0. 1 multiplied by 0, that's 0. So you can view the AND as some sort of multiplication if you want, or if that will make things simple for you. Okay, so as you can see, the results were 0 indeed, and that is what we expect. So now let's run this again using our new format, and let's see what the output looks like. So we say 4 and 2 equals 0, and we used f strings to actually get that output. So the ampersand came out exactly as it is, and in place of x, with the curly braces, we have a 4, which is what we expected. In place of y with the curly braces, we had 2, which is what we expected. In place of z with the curly braces, we had 0, which is the result of x and y. And I just showed how you get the result of x and y. Let's move on now to the next operation, which is the bitwise OR. And this is how you do it. So shift and a backslash should give you this. So now we're just going to change the operation. And this is the cool thing about variables. You don't have to change everything. So instead of us going back to this print statement and writing something like this and change it each time, we can change where we have the result, which is only at this point. And that result will then be updated over there. So we don't necessarily have to take this, put it there, and move it around. We can only change that once. And everywhere else where we have a Z, we'll have this updated or this new value. So this is what I was trying to show with f strings and variables. And also, we just have to change that thing so that we show that we've actually moved on to another operator. Okay, so now we're dealing with x or y. And the OR operator works in this way. You're going to say if you have at least 1, 1. So if you have at least 1, 1, then you're going to have a result of 1. So taking 4 in binary and 2 in binary once again, let's see this and that. We don't have at least 1, 1. So it's a 0. We do have at least 1 over there. So that's 1, at least 1 over there between these two. And that's going to be 1. This converting that into decimal form. So should be 6. So 6 is our expected result. Let's see if we do indeed get 6. So if you look at that, it says 4 or 2 equals 6. So that is what expected. So we've covered that. Let's go quickly to the next operator. So the Bitwise Not Operator. And this is the new operator which I didn't cover in the previous video. Now this only works on one operand. So we only need one of these. And remember that if I redefine Z, now this Z won't contain this line or the result of this line, but it will contain the result of the latest line that you've defined. So if I do this equals not x, then I now expect Z to have the result of not x. And we can go ahead and do this. But if you write a print statement below this with not x equals Z, both of these will be printed. So the print statement doesn't work like variable definitions. All print statements that are in your code will be found in the output. But with variables, only the latest variable will appear, or only the latest value will be the value of whatever variable that you're dealing with. Okay, so that is where the difference is. So now we're going to comment this out, and a shortcut to comment is Control and the / on the line that you want to comment out, or you can select a bunch of things and press that same shortcut and it should comment everything out. Or you can just manually come here and put the £sign or the hashtag and put a space, and you have your comment. So now we want to see the result of not x. Now you may be asking, what is not x, or what exactly happens behind the scenes? And this is what happens. So you're going to take your value in binary, which is 4, you're going to add a 1, and you're going to put these in brackets and put a negative to get the result. So minus, in here you're going to have 101, then convert this into decimal form, which is 5. So the result that we expect is -5. This is what the not operator does to our value. So now let's run this and see if we do indeed get that. So we're going to say not x equals -5, and we're happy with that. Moving on to the next operator. The next operator is the Bitwise Xo Operator, and it looks like this. So now we're just going to update this. We're going to erase this because we don't need it anymore. We're going to erase this down here as well. Then we're going to uncomment this line, and When you uncomment as well, you can also use the shortcut. It should uncomment the line that you are dealing with. So now we're also going to update that so that our print statement is updated. So even if I had the wrong operator, it will still give me the same result, because this operator over here is not the mathematical output. This is just text. It's a string, and whatever you put here doesn't really matter, doesn't affect the result. That is just text which is going to appear in the print statement. So if you look at that, it doesn't really affect anything. This is just for us to see or to remember what we're actually doing. So now in this case, we're doing the XOR. So I'd put that just for reference or just for us to see in the output. The thing that actually affects the computation of the result is this line over here, where I have the value of Z. And an interesting thing to note is that the output of the OR and the XOR in this case is equal. But with the XOR, what it does is it looks for differences. If you have a 1 and a 0, that would lead to a 1. If you have a 0 and a 1, that would lead to a 1. So it wants each of the bits that it's working on to be different. If they're the same, then it leads to 0. So let's look at these. These are the same. So we expect a 0. These are different. So we expect a 1. These are different. We expect a 1 as well. This is 6 in decimal form, and I've already ran this, and you saw that it was indeed 6. But let's run it again with the correct operator now in between the text. So 4 XOR 2 is indeed 6. So now the last two operators that we're going to deal with are related to shifts. So bitwise left shift. Let's talk about this one first. And it's shown by those two arrows. And what happens with this one is you're going to have this shifted this number of times. So the operand on the right is the number of times that you shift, number of times, and the operand on the left is what you shift. So what you shift. So now let's demonstrate this. So I have X shifted to the left Y times. So X is 4, I'm shifting it 2 times to the left. So let's see what the result will be or what's actually happening here. So 4 in binary is 100. If I shift that to the left by 2, I'm basically saying I'm moving everything by 2. So 1 will come there, that 0 will come here, this 0 will take the place of 1. And look at this, we now have a longer binary number, which means we have a bigger binary number. If you convert this into decimal form, this is 16. So that is what we expect to have. Now on the other side, the next one that we're going to talk about, which is the right shift, a similar thing happens, but numbers have the ability to fall off. So if you say X shifted to the right Y times, which is 4 shifted to the right 2 times, then this is the closing point, and if I shift this 2 times, it falls off. Shift this 2 times, it falls off. And finally, if you take the 1, shift it twice, it takes the last position. So with the right shift, we imagine that we have a fixed number of positions. So we only have 3 positions. And if we move this stuff, the 1 takes this position and everything else falls off, which means we fill in zeros for all the positions. That's also another thing which I didn't mention here. So these places are filled with zeros, right? And the same thing applies here. So you're going to fill the empty spaces with the zeros. So now let's look at this once more. So you have 1 0 0. You're going to shift each of these by 2. So the 1 should come there. This 0 should fall off. That one will fall off as well. So these are out of the picture, and you only have 0 0 1 because that place will be filled by 0. That place will be taken by 0. This last place is taken by the 1 that was in the beginning. So you only have 0 0 1 as your result because we imagine that we only have a fixed amount of spaces. So now we expect a right shift. So 4 shifted to the right by 2. Expect that to give an answer of 1. So now I've covered the left shift and the right shift. So let's run it in code and see if it follows what I was saying. So X shifted to the left 2 times. We said we expect to get 16. It gets bigger. And let's make our print statement follow that. So you say F, then X shifted to the left, Y times. So we can also do this or do it this way and take the actual value. So you should say X shifted to the left, Y times equals Z. Let's see what we get. And that is 4 shifted to the left 2 times is 16. That is what we expected. Let's clear the terminal. And let's come back here and now do a right shift, which we expect to reduce the value significantly down to 1. So if we shift, then we get a 1. And I already explained how you do all of these. We're just going to add this last one, which is the bitwise right shift, which looks like this. So that is all with regards to bitwise operations. And I'm sure this revisiting of the content made it more clear. If it didn't, feel free to watch it again. Feel free to leave a comment if you have questions. If you like the video, just give it a thumbs up. If you haven't subscribed, please consider subscribing, and I'll see you in the next video.